Assalamualaikum and hi. My name is Muhammad Firan Hakim bin Fazli. Today, we want to present about our project M6 electroplating using current density. This is our group member. First, Muhammad Ahmad Fakri bin Adnan. Second, Muhammad Fakrul Aiman bin Jamaluddin. Third, Muhammad Firan Hakim bin Fazli. Fourth, Muhammad Daniel Azizi. And the last one, Hisham. Abstract. Electroplating is a widely utilized electrochemical process employed for depositing a thin layer of metal onto a conductive substrate. This study investigates the impact of different current value on the electroplating process, aiming to optimize the coating characteristic and efficiency. The experiment involved the electroplating of a selected metal onto a substrate under varying current conditions. Various current values are applied during the electroplating process and their effect on key parameters such as the position rate, coating thickness, and surface morphology are analyzed. The study explored the relationship between the current density and the quality of the electroplate layer. By systematically varying the current, the research seek to identify the optimal condition for achieving uniform, adherent, and high-quality metal coating. The experimental result provide insight into the influence of current variation on the electroplating outcome. Analysis of the coated sample through techniques such as scanning, electron microscopy, and thickness measurement allow for comprehensive evaluation of the impact of different current values on the electroplating process. The findings contribute to understanding the electroplating mechanism and can guide the selection of optimal operating parameters for specific applications. This research is available for industries that rely on electroplating process, such as electronics, manufacturing, and decorative coatings, as it offers practical information for enhancing the efficiency and quality of electroplate product through controlled manipulation of current value. Introduction. The process of electroplating involves using an electric current to apply a thin layer of another metal to a metal object. The process is used to increase wear resistance, protect against corrosion, provide conductivity, or change the aesthetic appeal of an object. The process involves two electrodes, the anode and the cathode. The anode is the metal that will be placed onto the object, while the cathode is the object that will be placed. An electrolyte solution containing metal ions that will be placed is submerged between the two electrodes. When an electric current is passed through the solution, the metal ions are attracted to the cathode and deposit into it. Different current values can be used in electroplating to achieve different thickness and properties of the metal. Higher current density result in faster deposition rates and thicker layer but can also lead to uneven thickness and pore addition. Lower current density result in slower deposition rates and thinner layer but can improve the quality of the layer by reducing the risk of defect and improving additions.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Isham bin Muhammad Rijal. I will be explaining on the methodology. My metric number is CD220003, and the first step to the methodology is to figure out what metal will be coated with other metal. This step is very important because each metal has very different or very different substance in them. So you need to figure out how to use which metal to coat. The second step is clean your metal object to be coated. This means that you need to, the one that you want to coat, you need to the one that you want to coat, you need to clean it before you use it. Some object will be very dirty and some will be very clean. So how much cleaning you need to do very depending on the condition of the object before you start. On the third step is setting up your electroplating system. To assemble electroplating system, you need two metal objects, a container, electrolyte. This means electrolyte is like substance that you use uh, to transfer your coating. Uh, the next item is some wire and power supply. On the fourth step is coating your metal object. Now that your electroplating system is assembled, let's it run through the truly coat the metal object you are trying to protect from corrosion. Pay attention to time you kept it in the system and it keep track on how to clean the object. Both of these im- Both of these is will be impact your ability to electroplate metal to stick to your object. And the final step is to investigate a way to optimize the metal you're coating. Now that it's time to tune all your process to get the thickness and most durable coating can you can without taking too long without to the complete electroplating or using too much of coating metal. So what you can do is adjust how about the surface of the metal are you going to onto object, the separation of the two items in the electroplating bath, and the next time you run the electroplating bath, the amount of energy you provide to the system of your supply. This is what you need to know. This is what you need to investigate. Once you do the first trial, keep notes on how many electroplanes on each the additional object, so you find the final idea and choose your coating. Repeat as this in this experiment. You will repeat two, three time total of the trial. So you have done the first trial. Do you need to repeat the second and third one? Thank you.
So this is the result of the experiment. We have three samples of copper, 1, 2, and 3. So we test it with a different current, and we take the final weight after 30 minutes of electroplating.
I will continue for the observation. The electroplating experiment investigates various current densities, uncovering insight into deposition subtitles. Adjusting current density causes visible change in the electroplated layer, impacting thickness and quality. A clear correlation revealed the influence of current density on electroplating effectiveness. High current density led to faster metal deposition, suggesting potential improvement in coating performance. This understanding enhanced decision making for adjusting electroplating parameters across diverse industries. In material science and production, this knowledge contributes to developing advanced surface treatments and coating technologies, making us leader in precision engineering and materials modification for various industry applications.
Now we go through the discussion. Electroplating is common process for depositing a thin coating of metal on conductive surface. The procedure entails transmitting an electric current through a solution containing metal ion, which may cause the ion to be reduced and deposit on the cathode. The thickness and quality of the deposit layer may be modified by adjusting the current density, temperature, and other process variables. From the experiment, the effect of the different current level on the electroplating process were explored. The result indicate that as current density increase, the deposition rate and thickness of the foam layer also increase. However, as the current density increase, the quality of deposit layer decrease, as illustrated by the result. The electroplating process can be influenced by the type of metal being plated as well as the type of electrolyte employed. Metal with higher melting point require greater current density to accomplish the same deposition rate, as metal with lower melting point. Furthermore, electrolyte with larger concentration of metal ion can form thicker deposit at lower current density.
So for the conclusion, the electroplating experiment with various density levels unveils insight into deposition dynamics, present density influence, metal deposition rate, thickness, and quality. Increasing current density correlate with faster deposition, hinting at efficiency optimization. Beyond the lab, this finding enhance electroplated coatings in specific industrial applications. Precise current density control is crucial for adjusting the electroplating process, empowering researchers to optimize parameters for improved performance. The experiment significantly contributes to advancing electroplating, highlighting current density as a key factor in effective surface treatments.